Hi everyone, can you hear me?
Yes, we can hear you.
Yes, we can hear you.
A very good morning and good evening.
Good morning, Suresh.
Mm, Welcome to the sessions, guys. You know, just a couple of quick things before we start today's session. How many were you joining today? Who missed the demo and joined today?
Yeah, I'm
Hi,
connected
Suresh.
today.
Okay.
Yeah, this is Praveen. I also joined today. I didn't attend the demo sessions.
Okay, no problem. So basically today, last few minutes I'm gonna spend for Q&A guys because during our demo I was not able to spend some time there. And unfortunately call got dropped. Few people were able to join back, but for the sake of others, if you have any questions and answers, I'll be spending last few minutes in today's session. Okay. And let us start with our introduction. I just want to know about you two. Let me introduce myself first. My name is Suresh, and I have close to 12 years of experience into data engineering. Data engineering, when I say it's not completely data engineering, I started my career as a Hadoop developer. Throughout my career, I have been working on these distributed computing frameworks, MapReduce, Spark, and now completely into cloud data engineering. Okay, and I have close to
Hello.
4 to 5 plus years of experience in
Hello.
training.
అటెండ్ అయ్యాను ఇప్పుడే అయ్యానండి
Okay, so this is a brief introduction about me, and I want you to introduce yourself. You don't have to unmute, guys. What I'm looking for is name, your current experience, or your current technology, and then your experience in the chat window. Something like this. For example, in my case, Suresh, data engineer, and then 12 years of experience. So, for example, if you are a fresher, just mention like this in the chat window. Satya, QA automation 15 years. Okay. Hi, Satya. Sriram, SQL support 5 years. Hi, Sriram. Praveen, testing 15 plus years. Hi, Praveen. Nalinder, 8 years of experience in Oracle DBA. Great. Hi, Nalinder.
Yeah, hi Suresh. Yeah,
Hi, Sai Krishna. And then Naga, Teradata DBA, 18 years of. Hi, Naga. Ram, Salesforce developer, 3 years. Hi, Ram. Vinay, C++ .NET architect. Great. 15 plus years. Hi, Vinay.
Hi.
Hi, Sai Krishna. Hi, Ramya. Ramya and Sai Krishna, you mentioned you're fresher, right? You're joining from IST or from US. Mahesh, 15 years of experience, content developer. Hi, Mahesh. Sai Krishna from US. Cool. Srikanth, data analyst, 3 years. Hi, Srikanth. Srinu, 3 years, cloud engineer. Hi, Srinu. Which cloud you are using, Srinu? And what services you have used? Srinu, if you are talking, we can't hear you. Probably you can use the chat window. Great. So first of all, thank you so much, guys, for showing interest into our course. And I just wanted to know this introduction so that I would understand your background. Okay. Now let's get into the actual data engineering, guys. Just allow me a couple of minutes. I'll be right back. Just 2 minutes. Hey guys, I'm back. So yeah, so let's get started. Today, I'm going to talk about data mostly, where I'm going to walk you through what exactly data is. And then, we will talk about different data classifications. Uh, in yesterday's demo, I haven't deep dived into different types of data we have, right? I mean, the classification. Today, I'm going to do that. And then probably we'll talk about, different types of processing we have. And I'm going to give you some good understanding on how we are going to deal with data using Azure Data Engineering services. And probably I'll spend last few minutes in taking up your question Q&As. Okay, so let's get started. I'm not
Hi, 1 minute. Let me check with Suresh.
Okay.
Okay.
Hey guys, can you hear me?
Yes, yes.
Yes, Suresh,
Yes,
now we
Suresh.
can hear you.
Hey, sorry about that. It's been raining continuously in Hyderabad and we are experiencing frequent power cuts. Just give me a second, guys. I lost my host permissions. I think I have. Let me know once you're able to see my screen.
Yes, it is visible.
Yeah.
Just a minute. So let's try to understand, what exactly data is and different classifications we have. And like I was mentioning, right, let's try to make this session as interactive as possible. So, what is data, guys? Any idea? Any idea of what exactly data is?
Collection of raw facts.
Sorry, collection of raw facts. Okay.
It's a bits of information.
Sorry.
It's a bit of information. I mean,
Mm-hmm. Okay. What else you could think of? Okay. So basically, data and information, both the terms have, a different meaning, guys. We cannot club them both. Data is simply collection of some raw facts. I would say it's some numbers, strings, whatever attributes you have. Okay, so basically it talks about a particular object, as simple as that. It need not be talking about a particular object too, depending on the type of data we have, but it's some collection of some facts, as simple as that. Okay, so for example, we talk about student data. We have student attributes like student roll number, student name, student department, his address, so on and so forth, right? And then we talk about sales data. We have order ID, and then different items that were purchased in that particular order, and then price of each product, and then quantity of each product purchased, and then the final selling price, maybe if there is any discount, the discount percentage. These are all different attributes when we talk about attributed data. And your data can be as simple as what you're seeing on my screen. Okay, just copy and paste it in a file. It can also be data. Okay, and then your data can be something else too, which is providing you some facts. Okay, whereas information is completely different. Information is nothing but processed data, processed organized data, right? So here, if you look at my PPT, you might not find it bookish completely. Okay, so data from raw facts to strategic insights. Okay, so raw facts is your data, strategic insights is your information. I'll be talking about that a little later, but yeah. Now, yeah, understanding data classification. We were talking about these three classifications, right? Structured data, semi-structured data, and then unstructured data. Okay. So before that, just a moment. So we were talking about data, right? And data versus information. Okay, so data, we have discussed data as some raw data or raw facts, and then information as processed and organized data, which would help you to derive some insights. Okay, now talking about the classification, we were talking about three classes, right? One is structured data versus second one is unstructured data, and the third one is semi-structured data. Okay, now let's start with unstructured data. Any idea, guys, what exactly unstructured data is?
It's not a fixed format. I mean, the format is different.
Okay, what else?
I think it's comes under no SQL.
Mm-hmm. Okay, so let me explain. So talking about structured data, right, it doesn't have any structure attached to it. I'll be talking about what structure I'm referring to, but basically it's a unorganized data. To put it in a simple term, unorganized data, the data you see in your documents, your files, and then your multimedia, and then your HTML pages, they're all basically unstructured data. Okay, so just assume that I have to store student data. I'm just taking this example. Student data I wanted to store. Okay, so for example, if I have to store the data in a file in an unorganized way, so how would I store? For every student, I'll have a lot of text attached to it, right? Like a student bearing roll number XYZ with name XYZ have scored uh, some X marks in subject A, Y marks in subject B, Z marks in subject C, and secured a total of something, and then uh, percentage of Y and passed in distinction, something like that. Okay, so this is what we call as unstructured data. You will be typing all this thing into a document. Okay, a typical example for unstructured data, maybe for one student it is fine, maybe for 60 students it is fine, maybe a section. Okay, and what if you want to store for all the students in a college, all the colleges affiliated to a university? Okay, I mean, data entry is still fine, but let us assume maybe you want to query something from the data. Maybe I want to get all the students who have scored greater than 90 marks in subject C. So it's going to be nearly impossible, right? It's going to be a treasure hunt. You literally have to open that file, go through every single line, try to check how many marks a particular student have scored in that particular subject, and then you'll have to pick that name. Okay, so this is the problem with unstructured data. Storing is difficult, and also retrieval is even more difficult. Okay, so that's where structured data came into picture. So especially we stores data in a table which has rows and columns. Okay, now just a moment, let me open my Excel sheet. Now let's say I'm gonna store the same data. Okay. Firstly, I would be identifying some attributes. Attributes like student roll number, and then what else we have? Student name, and then his subject one marks, and then his subject two marks, and then his subject three marks. Maybe his total. We'll stick to this for now. Okay. Let's say roll number is 1001, name is Suresh, and then let's say subject one marks is probably 80, subject two is some 85, and then subject three is 75. So total would be how much? 165, 170, 240. Okay. And then 1002, then let's say Ramesh, and he got some marks X, Y. Z, and then some X again, total. Then 1003, Naresh got A, B, C marks, and then a total of X. Something like this. Your data is stored in the form of a table which is having rows and columns. Okay, so each horizontal one is what we call as row, and the vertical ones are what we call as columns. And the first row, what you are seeing here, right, which is indicating the attribute name, they are called attributes basically. This roll number, name, S1, S2, S3, they are called as attributes. Okay, so each column we identify it as an attribute. Okay, and each record or each horizontal line, we call them as records, and each record will talk about one object. Here the object is student. Okay, so rows would talk about each object of your table, and the columns would talk about each attribute of your a table, whatever you are storing. Okay, and now for us to store data something like this, there is a tool called as RDBMS, Relational Database Management Systems. Okay, so this particular software would help you to store data in this format. And here you are attaching the structure, right, in the form of the column names and also the column types. Column types is too early to discuss. We have something called as data types for each of these columns. So we are actually providing structure to the data we are storing in the form of column names and then column types. Okay, now, like I was mentioning, RDBMS is a tool, Relational Database Management Systems is a tool which would actually help you to store data in the form of a structured format, in the form of rows and columns, basically. Okay, not just that, RDBMS will also provide you with something called as SQL. So SQL stands for Structured Query Language, using which you can actually retrieve the data. Say, for example, we'll take the previous use case where we'll have to get all the students who have scored 90 and above in subject 3. Okay, so SQL looks something like this. Select star from, let us assume this table name is students, where S3 is greater than 90. Okay, so even if you don't know what SQL is, you can still be able to interpret what this particular query is doing, right? Select star, meaning I'm selecting all the columns from where? From students table. Okay, so here we have added a condition, and that condition is subject 3 mark should be greater than 90. Okay, so your RDBMS supports something called as SQL, using which you can actually retrieve the data by just writing these queries. This is how RDBMS was able to solve the problem of storage and retrieving your data back. Now, let me take a pause. Are we good so far?
Yes.
Yes, no, maybe.
Yes.
Yes. Yes.
Third one is semi-structured. Any idea, guys, what exactly semi-structured data is?
Maybe JSONs, XMLs.
Perfect. They are the examples, but what exactly semi-structured data is? So it stands in between structured and unstructured. Okay, so basically, when we talk about semi-structured, right, the data is not typically stored in RDBMS in the form of a table, but you still have some structure attached to it. Okay, typical examples are your CSV files and then JSON files, CSV files, and then JSON files, and you have XML files. They're all semi-structured, right? Let's say I'm taking a .csv file, same students .csv. So this is how data in your file would look like, right? First row will be a header where you have first row header where you have all the attribute names like student ID name, and then subject 1, then you have subject 2, then you have subject 3, then you have subject or maybe total, something like this. And the data would also be stored in comma. I mean, data would also be stored in rows separated by columns separated by commas, something like this. One zero zero two Ramesh, C, something like this. Okay, and when you talk about JSON file format, right? Students, dot JSON file comes with a dot JSON extension. JSON stands for JavaScript object notation. Okay, so here the data would be stored in the form of key value pairs enclosed in a curly braces, something like this. Okay, so this indicates one record uh, where you have ID. ID is Suresh, and sorry, ID is 1001, and each record is separated by a comma, and then name is Suresh, comma, and then subject one marks some 80 or whatever it could be. Key and value pairs are separated by a column, and each attribute is separated by a comma. And then subject 2, maybe 85. Okay, so only 4 attributes I'm taking, and then the second record starts, something like this. Okay, so this is how your JSON data would look like. So if you observe, you still have data attached, sorry, structure attached in the form of key value pair. Okay, now moving on to the third example of semi-structured XML. So don't worry, guys, if you are seeing these file formats for the first time, CSV, XML, or JSON, we will be dealing with these file formats throughout our course. Okay, so JSON will have a custom, sorry, XML will have structure attached in the form of a what you call custom tags. Okay, so initially you have a root tag, and then root, and inside root you have a row tag, row, and then row. If you are wondering what these two tags are, this is the start tag, this is the root tag starting, and this is the root tag ending, and this is the row tag starting, and this is the row tag ending. Okay, and inside this row you'll have data in the form of tags. ID, let's say ID value is 1001, and then ID tag ending, and then name, then you have name value, and then name tag ending. Okay, and I'm just taking only two fields, which is ID and then name. Row ends here, and then new row starts, new row, and this is new row ending tag. You'll have the data in the form of tags again. ID, Ramesh, sorry, this is name tag, right? This is name value, name, and then you have ID 1002, something like this. ID. So this is how your XML data would look like. So root tag indicates the start of the file, and this root tag indicates the end of the file. Okay, and this row tag indicates the start of each row and end of each row. Inside this row tag, we have the attributes also listed with the tags. Let me take a pause. Are we good so far?
Yes, Suresh.
Yes, Suresh.
Okay, I'm going back to this presentation. Now, just you can try to understand, guys. Structured data organized into formatted repository, typically a database with rows and columns, easily mapped into pre-designed fields. Semi-structured doesn't reside in a relational database, but has organizational properties, making it easier to analyze. And then this is unstructured, not organized in a predefined manner or without predefined data model. Okay. Now, I'll be sharing this PPT with you. You can go through it whenever you have some time. Okay. But yeah, this is the comparison chart I wanted to show. So this first one is for structured, second one is for semi-structured, and third one is for uh, unstructured data. So technology, we use relational databases, and then XML, JSON, CSV are the examples for semi-structured. And here you can have anything, character, binary, whatnot. And then flexibility, here it is always schema dependent. Schema is nothing but the column names and column types which we were talking about. Okay, so whenever you are inserting data into a table, it has to be strictly confined to that schema only. Okay, meaning if you have 6 columns in your table, when you're inserting, you'll have to make sure you are inserting only 6 values, neither less nor more. Okay, so JSON, you have more flexibility. In one record you can have 4 commas, in the second record you can have 5 commas, which tamper the schema. But that's where we'll have to come into picture and solve it. And here it is completely flexible. It doesn't even have schema, so it doesn't even have structure. So we don't really have to worry about schema. Okay, and then we'll talk about this transactional versus historic data. Any idea?
Transactional means real-time data.
Transactional means real-time data. Okay.
Historical means old data. I mean, it could be one
Okay.
day, or 1 year, or 10 years, whatever. It is used for analytical purpose.
Yes. That's the term I'm waiting for. So before we jump into this classification, so we were talking about data engineering, and then we were talking about data, and we discussed about different types of data, right? Structured, unstructured, semi-structured. Can you guess what type of data we will be dealing with more often in data engineering?
Unstructured data.
Sorry.
Unstructured data.
Okay. Any other guesses?
Most of the time it is unstructured, and we work on
Even structured data also,
yeah.
Mhm.
we will be moving to, I mean, for a data analytics purpose, right? I mean,
Hmm.
because here it is more of analytics. Not we are not dealing with any of the transactional data. We are making a insight of the data, right? I mean, we'll move into a different system and then getting the
So what
extracts of that.
we make sure that we bring that data into a organized format for our analysis.
So 99% of the time, we will be dealing with structured and semi-structured, guys. So only 1% unstructured, or even less than that. Okay. So most of the time, most of the people thinks that we deal with unstructured when it comes to distributed computing environments or this thing, right? The reason being, most of the services supported are marketed in such a way. Okay, so big data ecosystem, or all the Spark environment or Databricks environment or whatever services we are dealing with, they're all designed to handle huge amounts of unstructured data. Yes, you can store huge amounts of unstructured data, but still, when we talk about real world scenarios, and then real time projects, 99% of the time you will end up with dealing with structured and semi structured data. Structured data which you already have in your organization, RDBMS or data warehouses, or maybe any other systems like SAP. You have data in the form of tables. Likewise, Salesforce, you have data in the form of tables. So any of your systems, your organization systems, right? You will end up having data in a table. Okay, which means they're all structured. Now, second, now you purchase data from the third party, or maybe you try to download data using REST APIs in real time, or maybe some system is generating data for you. Okay, so they're all semi-structured. Either you will be receiving .csv files, or maybe you'll be receiving .xml files, .json, REST APIs. Anyway, the REST API response is always JSON. Okay, so most of the time you will end up dealing with structured or semi-structured. I would say 99.9%. At least in my 12 years of experience, there was only one project that too I have dealt using Apache Spark back in 2016, where I was working for Ernst and Young for a project called Forensic Investigation and Dispute Services. I'll be talking about that project too, so that you will be able to understand how unstructured data can also be handled. But I want you to understand and realize, in the real-time projects, we would end up dealing with structured and semi-structured data 99.9% of the time. Does that make sense?
Yes, yes, Suresh.
Okay, but you go to any introduction page of any of these services, they'll always highlight the unstructured part. Okay, now moving on, I wanted to talk about this classification as well, transactional and then historic data. So talking about transactional data, right? It's the real-time events that is getting captured, as simple as that, or the current data, I would say. Let me give you some examples. Say for example, you want to purchase something, right? And then for that, I mean, using any e-commerce website, for that, the first step you'll have to do is login. For logging in, you'll be providing your credentials, username and then password. Okay, so the moment you have provided username and password, it will have to go check in the database if the username and password is matching. If it is matching, then you will get a success response, uh, which redirects you to the homepage of the uh, homepage of the e-commerce website, whatever you are looking for. Now, the data you have provided here is a username and then password. Best example of a transaction data. Okay, and then once you are into the home page, you want to look for products. You search for the product you are looking for. It will go hit the database and display the catalog of products they have. Transaction data. You have purchased it. Your purchase information, transaction data, and then maybe you want to modify your address. Transaction data. You want to add your cards, remove your cards. Transaction data. Okay, and then maybe you want to go through the feedback, or maybe you want to go through the reviews, transaction data. Okay, so what is historic data then? What
Some
is historic data then?
orders which we did,
Sorry.
orders which we have did under the search box history.
Mhm. That's correct. So basically, historic data doesn't have any definition, guys. Saying that any data which is older than 1 day is historic data. No, any data which is older than 20 days is historic data. No, there is no such definition for historic data. But the data what you use for analytics is historic data, and the data what you use for doing transactions is transactional data. So when I say the data you use to do transactions, it has nothing involved with the bank transaction or financial transaction. A transaction is nothing but a query to a database. Okay, so for example, login is a transaction, searching for products is a transaction. Okay, so these are all real-time events. So the transactional data only supports these real-time events. Okay, so any activity you do in a website, any registration you do, any sign up you do, or any product you search for, any order you have placed, they're all transactional data. Now, what is this historic data? So basically, we separate tools as well. When it comes to transactional data, your data would be stored in RDBMS. Okay, and this RDBMS is really good for uh, querying a single record or querying a group of records. Okay, this is not optimized for analyzing your entire data. Whereas, whenever you deal with this historic data, right, here you have a specialized tool called a data warehouse. Okay, specialized tool called data warehouse. So what we usually do is all the orders you have placed, all the products we have, all the users we have, generally we push all the data to this data warehouse. We push all the data to this data warehouse. Okay, probably once in every day, or once in a week, once in a month, depending on how much incremental data that is getting added. So what do I mean by incremental data? Let us say, again, I'm going back to the same retail example. We have users data, and then let us assume you also have products data, and let's say you also have orders data. Okay, and you also have sales data. So orders data will have only your order information, and sales data will have your sales information or sales attributes. Okay, now every day new users will get added, every day new products will be added to our catalog, every day new orders will be placed, every day new sales would happen, right? So all this data, whatever is being added in a day, we keep pulling that data to this data warehouse. The moment the data is moved to data warehouse, we refer to that data as historic data, and this is predominantly used for analytics. Okay, it could be running your machine learning algorithms, it could be building your business reports. Okay, the main use case is BI reporting, business intelligence reporting. So this data would be consumed by your any reporting tool. It could be Power BI, it could be Tableau, it could be MicroStrategy, it could be anything. Okay, and the process of moving data from RDBMS to data warehouse is what we refer to as ETL. It's not just RDBMS, it could be other sources too. It could be some files, it could be mixed with some MDM processes. MDM stands for metadata management. It could be any other files I purchase from the third party organization, and then I extract data from that source, and then transform into the format where my BI users can readily use it from, and then finally load it to a data warehouse. And for doing this ETL, we have multiple tools like Informatica or Talent, to name a few, but there are multiple tools. Okay, so this is the beauty of historic data, guys. You can use this historic data for analytics. You can use this historic data for running your AML algorithms, a lot of things. Okay, and one more difference I want to highlight here is transactional data follows relational data modeling. Okay, so when I say relational data modeling, we talk about first normal form, second normal form, third normal form, boy scout normal form, different normal forms we have. And when it comes to historic data, the data modeling here is dimensional modeling. Okay, so here we have facts, dimensions, and when we talk about dimensions, we have slowly changing dimensions, type 0, type 1, type 2, and then we have schemas like star schema, snowflake schema. I'll be talking about those things as well. We have a separate topic for data modeling, guys. Okay. Now you might ask me, boss, who deals with transactional data? Who deals with historic data? Transactional data, we don't deal with transactional data, guys. Data engineer, by definition, don't deal with transactional data. Transactional data is dealt by software engineers who actually built those websites or those real-time applications. They design the normal forms, they design the database schema, how it should look like, and then they insert data from the real-time events that are happening from their sources. Okay, so data engineers, we deal with historic data. Okay, so that is the name. Earlier, people used to call us as ETL developers, Hadoop developers, Spark developer. Now they have merged all of them, and then calling us as data engineers. Expectation is that we should be doing any task related to dealing with historic data. Let me take a pause. Are we good so far?
Can you come again with what is dimensional?
Dimensional modeling is best suited for a reporting body. Okay, so I haven't given any definition for dimensional modeling yet, but like I was mentioning, it has a lot to deal with facts and dimensions. Maybe these nomenclature might sound French and Latin for you at this point in time, but like I was mentioning, we have a separate session to talk about dimensional modeling. Okay.
Okay.
Just for now, I want you to understand we use a different data modeling for storing historic data or dealing with historic data. Let me take a pause. Are we good so far?
Suresh, one question, like,
Yeah,
so
please.
we need to convert this, like, the structured data to, like, from the ETL, we have to do it, and then we do use that data for analytics. So here the data engineer role is we need to do this ETL and then do the reporting as well, like the analytics.
Reporting generally we don't do. Okay. But we do have some understanding on how this reporting tool works. Yeah, certainly we don't do reporting. We are not reporting folks. And again, it's not a hard and fast rule as well. There are organizations where they depend on data engineers to do the reporting as well, but they understand it's not their core skill and they don't expect them to create some advanced reports.
Okay, here the data engineer role is converting this RDBMS or other sources data to data warehouse.
This
That's
is
the data engineer role will end.
this is the traditional flow I have given you, but cloud it's completely different. So we'll not be using these tools. This is replaced by ELT processes, which we'll be talking throughout this course. Okay, but yeah, data engineer role ends given the last layer of data. If I would say
So,
here in this format,
Just
this
to
is the
add,
last layer of data you assume, there ends your role.
okay. So from there, like the analytics, like whatever this from the Power BI team or the BI tools will use this data warehouse data and provide the analytics.
Yes, like I was mentioning, sometimes you might end up doing it, but definitely not AIML. AIML you will not be doing for sure. But reporting, sometimes they might rely on you as well. Okay, some basic stuff. So again, just in a couple of projects, I was doing Power BI reports as well, just because we don't have data analysts. Okay, but on paper, it's not your role. Nobody would expect you to do it. If they are assigning you some tasks, they would expect you would need some learning time as well. Okay, but nobody would expect reporting skills from a data engineer. I think I
Okay.
have answered your question.
Yes.
And same with the data science also, right? I mean, they'll not expect us to do modeling and then analyze
No
that,
way.
right?
Data
Correct.
science is not our cup of tea for sure. At least reporting, though, we can do it because
Yeah,
we
yeah,
know what histograms are, we know what pie charts are, what a line chart is. So at
correct,
least we can do some reporting. But AIML, it's completely disjoint.
correct, correct.
Okay.
Maybe
So
our data
what's the
will be
difference,
there.
like data engineer and data science?
So data engineer, you will prepare data for a data scientist, and once you have the data ready, he would be running his algorithms using the data provided by you. A data scientist cannot go and fetch data from RDBMS. He cannot do this ETL.
Okay.
He cannot write PySpark code. Okay, so he knows what data he need or how the input data for his algorithm should look like, and he knows what output he is getting and how it would help the organization. But you are the one who would do the heavy lifting. Okay, so once he models his algorithm, he would be providing us with sample inputs. Boss, this is how my sample input should look like. These are the columns I need. These are the columns I need in this particular format. Now it's going to be you who would go do whatever is needed to get that data to him. The data could be residing in multiple sources. The data needs multiple transformations, sometimes more complex transformations. So you'll have to do whatever it takes. So for me, right, if you ask me, who is doing the major lifting or heavy lifting, it's data engineer.
Okay.
In the early days of my career, data scientists used to have more salaries than data engineers. But these days, I'm seeing data engineers and data scientists making almost same. In some cases, I have seen data engineers making more than data scientists.
Yeah, I have
The
seen that
data engineer.
scenario recently in my organization as well. But one thing, Suresh, see these days in this modern IT, we can see as everybody is discussing AI and machine learning are replacing many technologies. See what are all those technologies we are seeing in our reels and all that is different. But in reality, does data engineering also will be replaced? By
I'll
AI?
ask you a simple question. I can't see your name because I'm using a single screen.
Okay.
But let me ask you a simple question.
Mhm.
So, can AI work without data?
No, but data will be loaded by developers and all, right? See, we are managing the data. That is
Who
a different.
developers?
Hello.
No, without you, AI cannot work. Data fields are something which AI can never replace.
A
I can
data
give you
engineer is a
example.
support based or it's a developing based.
Which one? Sorry.
Data engineering is a support based work, operational work, or it's like a developing based organized work.
No, yeah, development work. Who
Okay.
would pay such amounts of salaries for support work?
Yeah. Mm-hmm.
And if you see the PPT I'm showing you, that is generated by AI. Okay, so I have taken help of AI. It doesn't mean that AI can come and teach this course. You see, this is the PPT I was able to create by giving a lot of prompting. So this is not the first cut version. Okay, so once this AI has prepared this PPT for me, I literally have to go and give the prompting for each slide, what I need, what I don't need. Okay, so you'll have to make up your mind to coexist with AI.
Okay.
Okay, it's not like AI replacing you. Maybe web development or any coding roles AI can replace because they're all standard templates. Okay, so which AI can go search from the internet and then get it, right? But when it comes to data engineering, maybe there are a couple of DBS, they might have experienced it as well. So the quality of data, governance, and a lot of other things, right? They are the few things which can never be automated. And also, there are some areas some areas and some companies which are not ready to use AI, especially into banking and finance sectors. So
Okay.
my friend is working for JPMC, and they have made it very clear. They have added wrappers to the LLMs, and the usage of AI for them is limited only to prepare these PPTs, documentation, and other things. Okay, and to some extent they are using ChatGPT as well, but inbuilt wrapper. They are not using any APIs, outside APIs. Likewise, another friend of mine is working for Bank of America. Their adoption to AI is only limited to GitHub Copilot. It was very clear. And I can give you another example. What happened with Klarna recently? So they have replaced engineers with AI, and after something went wrong, they have to pay a hectic fine, and they started recruiting back. Okay, so I'm not saying AI is a myth or AI can't do anything. AI can do a lot of things. Okay, but it will have to coexist with us. Replacing developers can never be done. No way. Not just us, but any developer. Okay, and it is even more difficult in our case, folks working on data. I hope that answers your question.
Yeah. Okay, Suresh. Yeah.
Suresh, one more question. How it's different from Azure Data Engineering to like this big data?
It's see, that's what I'm mentioning, right? It's a data engineering. It doesn't matter big data, small data, less data, very less data. No. Okay.
Mhm.
So data engineering is a data engineering. Your file size could be few KBs or a few TBs. You'll have to deal with it. First, you'll have to understand what services we have, what capabilities they have, and what is the right tool in order to deal with this particular data. Okay, so at the end of the day, what you do is ETL, but what service you are using to do that ETL should be defined by different other parameters, like whether it is kbs of data or whether it is tbs of data. You need a distributing computing framework, or you need a single core processing framework. Okay, so again, like pandas versus pyspy, distributed versus non-distributed. Maybe your question should be cloud versus on-prem. Okay, so coding front, it's almost same spark, but cloud make your life easy, very easy. But costing wise, you'll have to be very careful. On on-prem, you don't really have to worry about costing and other things because it's a one-time investment. But when it comes to cloud, you have to be very careful about costing.
Okay,
Okay.
Suresh, I have a small, I mean, it's a
Mhm,
question where it relates to me only. See, I'm working
mhm,
as Oracle database engineer. Okay, I mean Oracle database administrator. In
mhm,
our company, I'm also dealing with the data warehouse, but I'm just working on very little stuff. Okay, like for every 3 months, we get a ticket, and we are maintaining RQs also. Okay, it's a
mhm.
terabytes of data we are maintaining. One okay, apart of all this, how easy I can switch to data engineer. So how easy it's a bit little I need to go with a lot of research, or how it is compared to other technologies. See, here I'm C++, .NET people are also here. Okay,
Mhm.
and some few others are asking for cyber security there, and I'm data base engineer. So how it is easy or how much it is difficult to switch to the technology?
It doesn't have anything to do with your background, buddy.
Mm-hmm.
Okay, so that is something which I have to make it very clear. If anybody is under an assumption that just by attending my sessions you'll be able to clear jobs or switch your career into data engineering, you can drop off from tomorrow. Okay, I'll be brutally honest because I don't want to set up any wrong expectations. Okay, so you will be able to crack interviews, you'll be able to work into data engineering only when you put double the efforts what I put. I mean, double the efforts to what I put in the sessions. Let's say my sessions will serve maybe 40 to 50%, but it will give you a head start. Okay, it will give you a direction. What are the questions you're asking, right? No question is naive, no question is intelligent. Okay, but you will be able to answer all these questions by yourself by the end of this course. Okay, and after this course you don't have to get into uh, what you call you don't have to get into any other courses. And also yeah, I have expected this kind of a discussion because we didn't do FAQs yesterday, sorry, Q&As yesterday. But yeah, effort from your side is very much needed, whether you are a fresher, whether you are an experienced person, whether you are coming from a different background. So how much effort you are putting is what matters. It's not like I just attend the sessions just because I have come from ETL background or DBA background, or I pretty much know SQL. Maybe you will feel little more comfortable in the session, but until and unless you practice it, nothing will happen. That's the thing which I really want to make it very clear. And secondly, I'm not sure how many of you have got a chance to go through the second recording of yesterday's demo, day before yesterday's demo. I have mentioned about one-on-one sessions which you have to do after this course. Okay, so I'll be talking about resume making, and there I'll be guiding you with what is needed for your experience. So, for example, you are a fresher, you are 2 3 year experienced guy, then you don't need anything more than my course. You can happily start attending interviews and crack interviews for sure. I can guarantee you. Okay, but if you are having maybe 3 to 8 year experience zone, you'll have to put 30 40% more effort on top of what I have delivered. Maybe you are 10 15 year experienced. Again, if you are working from US, it boils down to your role. Because in US I have seen people with 20-year experience working as an engineer and with 4 5 years of experience working as an architect. Okay, so if you are aiming for that architect role, then you'll have to put at least 60 70% more effort to what I have already covered. Okay, but like I was mentioning, I'll be connecting with you one on one. We'll try to understand your aspirations and will guide you towards what you need. But for that, I want you to have some knowledge. On the day one itself, I cannot tell you, what is needed for you to get into a role you are looking for. By the end of this session, we'll connect, we'll see where you stand, and I'll guide you accordingly. Hope that answers your question.
Yeah. Okay, Suresh, this is second class or third class, Suresh?
This is first class.
Okay, so technically it is first class.
Technically, not technically. In every way, this is the first class. The last session was a demo
Okay, so okay, fine. I will go through the demo session once. What was
and
happening.
not needed, honestly. It's a
Oh,
subset of what we have discussed today.
okay, fine.
Suresh, even I do have like a similar questions like this one. I came from the testing background. If I want
Mhm.
to switch this role, like what is my learning curve? Like what is how should I target it?
So my
So
answer
like
is generic earlier. Like I was mentioning, yeah, you'll have to put in efforts. It's not
Mhm.
going to be easy for DBS as well. They have never seen Python in their career. You can check with any DBA, you can check with any ETL developer.
Okay,
Okay. So learning curve would be same for everyone. Just that they know SQL better than you.
okay,
Okay, and I'll be teaching SQL anyway.
sure.
So it's all about your efforts. What matters is your efforts, not what I deliver. Okay.
Yeah, got it.
So
Suresh,
I'm not
small
gonna put
question.
anything in sugar-coated way, guys. Sorry for being brutally honest, but I mean, I hope this would help you to take a wiser decision.
Yes, definitely it will help us like to decide, right? Like whether to stick to it or to drop
Yeah,
off.
efforts
Yeah.
definitely you'll have to put. I have seen people getting succeeded, guys. I'll give you a simple example. Back in Jan, I was very demotivated because from past 6 months, that is from July 24 to December, I have been taking batches, but none of my participants were able to clear the interviews because for me, completing this batch won't give me leads. Okay, so let's say maybe one of you or couple of you have cracked interviews. That will bring me 10 more students. So my target is always to get you into a job. And there are instances where I have gone to a lot of extent to help students, not by taking proxies. I just want to make it again very clear, not by taking proxies, but guiding them with everything they need to clear the interview. Okay, but from January onwards, I started observing a shift in the requirements. In the last 3 months itself, almost five of my students got jobs into data engineering, and one from India and four from US. I usually save those screenshots as well. I feel really happy when they share their success story. Okay,
Yes.
so it's all about efforts. It might take 2 months after your course, 3 months after your course. I still remember there was a student called Bhavani. I trained her in August 2024 batch. Okay, and she got job in March 2025. She never gave up, and I have been constantly supporting her. Okay, so it all depends on you. It only depends on you, not me.
Suresh, so one thing. Do I can do this data engineering in my laptop for practice purpose by
Yeah, yeah.
installing in it? Okay.
You have a browser, you can do it everywhere. All
Oh,
you need is a browser
okay.
because it's all cloud.
We're dealing with Azure, yeah. And okay, and one more thing. So, do I need to learn any prerequisite languages for learning this data engineering? See, for DBA, a little bit of SQL is enough. Like that, any proactive course you are going to suggest for us? I mean, better to cope up with that language also for learning this like that.
I would say basics of Python will do.
Okay.
I
Mhm.
can tell you the topics as well.
But I don't have any knowledge on Python. Do I can suffice with this for learning this data engineering?
Definitely yes.
Okay.
I can confidently tell you. Even without knowing, you can write applications in PySpark.
Hmm. Okay.
Okay, so if you are not able to understand PySpark code, or if you are not able to understand what I'm doing, you can, question me. This is something which I can assure you. But the way you write code, if you know Python, will change.
Okay.
Okay,
Okay.
so there is one website called Java T Point. Uh, is it changed to T Point Tech? Yeah, this is the one. It's T Point Tech now. Earlier it was Java T Point. So here you can probably learn Python control statements, Python data structures, Python functions. Modules is not needed. Yeah, probably you can learn till Python functions. Okay, so Python functions, and then Python data structures, very important. Python control statements, very important. Variables and data types is anyway basics, and then some basic thing. So that should do
Okay. This makes us to learn at least for 2 years of experience. Till the functions is enough
enough.
from Python basics. Yeah.
Yes.
Okay.
Okay. Any other questions, guys?
Suresh, I have a question.
Yeah.
Um, this there are a lot of tools are there, no AI coding tools. Uh,
Mhm.
are you also referring or suggesting which tools can be used here for the PySpark?
ChatGPT.
Because
I use ChatGPT only.
but some organizations will not allow ChatGPT, right? I mean, can we use Copilot also for this PySpark?
Copilot, I'm not sure because in our organization, due to the restrictions, Copilot is installed in my Virtual Studio Code, Visual Studio Code,
Okay,
and Databricks code. I write it there. Databricks AI is there. It will provide you with some useless information, useless tips. Okay,
correct, correct.
but I'm still relying on Google
ChatGPT.
only.
So I mean, ChatGPT is the best way. That's what you're telling, correct?
ChatGPT is the best way. At least it will give you some relevant answers.
Okay, okay, okay. I mean, you are in this course. Are you also teaching how to ask or how to give a prompt to ChatGPT so that we get a relevant answers?
No, yeah,
How will you? No,
that's
right?
out of scope.
Okay, okay. Are any links or any content on that?
At least at this point in time, I would say no because our sessions are already overwhelming.
Okay, okay. No, no. I'm just telling. Is there any YouTube links or some references how to like you have a thought like you have something in your
I'll try to get something for you because in my case, right, I already have 12 years of experience,
uh
almost 8 years in Databricks and cloud.
Okay, okay.
Okay, so I pretty much know what to prompt and what not to prompt.
Correct. See, because I'm doing one project in PySpark recently in my
Okay,
in my office. So
hmm,
what I don't know anything in PySpark, but what I'm
got
doing is I go to whatever whatever thought comes to my mind, I will go and put it in ChatGPT. Whatever code I get it, I'll come and put it. Since I'm a developer, I know what to do, what change I have to
yeah,
do. That's how I'm proceeding. I'm making
got
progress, but
got it.
I, is there any structural way of doing properly? That's what I'm
When I
thinking.
today is 12th August, we will talk again on 12th September. You'll see a lot of difference.
Okay, okay, okay. Got it. Okay.
Okay, trust
Mm.
me. You can schedule your call on 12th September with Career IT folks one on one with me, and then we'll discuss what progress you are able to make.
Okay, fine.
Okay.
Okay, fine, Suresh. So Suresh, one more question in case if you have
Mhm.
any questions, is there any channel to contact you?
Careerity only. Unfortunately, we are not supposed to directly contact each other. There are
Okay.
some terms and conditions I have to abide by.
Okay.
So,
No, no. In case of any questions or doubts.
Careerity directly, you can ping Careerity folks, and they'll get in touch with you.
Okay. So in case if I want to talk to you via,
Same Careerity.
I have to talk with them only. Okay, fine.
Yeah,
Perfect.
you'll have to talk to them. They'll schedule a Zoom call with you and me.
Okay,
One on.
fine. Yeah, perfect. And Suresh, can I get your LinkedIn profile link or something? Just
At least not now.
okay, 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 no issues.
Okay, because just like you are participants, right? I'm trainer working for Career IT, so we have some strict rules, strict
Okay,
guidelines.
got it, no issues.
Okay, cool. Any other questions? Great. Thank you all. We'll wrap up this session, and we'll meet tomorrow. And sorry, guys, a session was extended for 20 minutes, but I don't want to stop in between for Q&A.
Yeah, Suresh,
Okay.
one question. Suresh,
Yeah.
last question. Yes.
Yeah, please, Mahesh, go ahead.
Actually, uh, for 15 years of experience, you should get of your this thing that your from your side it will be 60 to 70% something. That isn't it?
Sorry.
I'm audible.
Yeah, your voice is little breaking, but yeah, please go ahead.
Yeah, yeah. You said that the person, as per based on experience, we need to do from our end, isn't it?
Mm-hmm.
Our effort. You mean to say yes.
Yeah.
Okay. For 15 years of experience, people, how for architect level, will you provide any information or any this thing for us?
Yeah, definitely. Like I was mentioning, right, in the one-on-one session, which we are going to connect after this course, I'll be letting you know what you need to do apart from what you have learned in this course. That's your path to architect.
Okay, okay. Because we have access to the experience on different fields, and the showcasing of resume will be different, and the role
Mhm.
will be different. Right? That's the reason I'm asking.
No, no, that is the beauty of software engineering. I mean, software roles, right? At least IT jobs. It's very dynamic. Even I have worked on multiple things which are not part of data engineering. Okay.
Okay.
So that shouldn't be a problem. As long as you have good amount of knowledge, you are able to illustrate it, that should do.
But thank you.
Cool. Thank you all. See you tomorrow. Good day and good night. Happy learning.
Yeah,
Thank you.
yeah. Thanks, Suresh. Bye, bye, everyone.
Bye. Bye, everyone.
Bye, bye.